Frank, you've criticized the prevailing inflation theory, which solves a lot of problems in cosmology. Why?
I think we can explain everything, all observations that inflation purports to solve, without using the new physics which inflation tries to bring in. I think we can use only known physics, physics we've seen many times in the laboratory, to explain everything. For example, let's take the flatness problem. Why is the universe so enormous in size? My answer
and so similar.
And so similar everywhere. There are two separate questions. One is the horizon problem, the other one is the flatness problem. They're really the same. They all come from quantum mechanics. Quantum mechanics tells us that when the universe was extremely small, that there was no possible variation allowed in the early universe. Even though these areas were not in causal contact and never had been, quantum field theory is a global theory, and it restricts the number of possibilities to one. This region had to be at the same temperature as this region because quantum field theory did not allow any variation. It's that simple. Simple, known quantum field theory. Now let's also consider the situation of the universe being very, very small, but a quantum mechanical universe. All of these universes of the multiverse are gripped into one small size. It's almost as if they were a coil spring. When time began, the universes then expanded outward rapidly as a coil spring.
The universe is expanding, the expansion is accelerating, the universe is flying apart. Is this reversible?
I think it is, Robert. I think we have to understand where it comes from, this acceleration. If the acceleration were turned off, there were no problems because we know from physics that the universe has to be closed, although, of course, extremely large, very close to flat. But the acceleration is the real problem. If the acceleration were to continue, well, we would not be able to see anything outside roughly our own galaxy and maybe the Andromeda galaxy. Everything else would just disappear forever outside of our contact.
And then eventually everything itself would
disintegrate,
evaporate or whatever.
Yes, it would be all over for life. It would be all over for any possibility of having purpose in the universe. So the question is, can the acceleration be turned off? The question can only be answered if we know what is causing the acceleration. Fortunately, the Standard Model tells us what it has to be. The Standard Model tells us, of particle physics, which has been confirmed by all experiments we've been able to conduct to date, says that the entire universe is filled with a vacuum energy coming from a Higgs field, which is the field that gives mass to all the particles and also does some other important things. But another thing that the Standard Model can do is it tells us that this Higgs field has an enormous energy. It's gigantically larger than normal energy densities which we're familiar with. So why don't we see this? Well, the Standard Model can give us only one answer. There is another force out there called the cosmological constant. If the Standard Model is consistent, these two must almost precisely balance. The cosmological constant forces the universe to accelerate. The Higgs field, by its very nature, if there's no cosmological constant there, would bring it back together, cause the whole universe to collapse into itself.
So I know what you're saying is the cosmological constant is a little stronger.
A little stronger than the Higgs field. And we have to ask why. One of the great mysteries of cosmology, which fortunately the Standard Model can solve, is why is there more matter than antimatter? The Standard Model has a natural mechanism for generating more matter than antimatter. Now, in the process, what it will do is slightly, this matter creation process, slightly lift the Higgs energy above where it would naturally perfectly cancel the cosmological constant. So the cosmological constant, the accelerator of the universe, is now partially uncancelled, and so the universe is accelerating. To stop the acceleration, all we have to do is reverse the matter creation process. If we reverse the matter creation process, annihilating matter, then the universe will return to its minimum state, canceling the cosmological constant, stopping the acceleration. Why should we do that? Well, one of the things living things have to do is Feed on energy. Survive. That's our main goal, is to survive. What do we have to survive? Energy in one form or another. We eat food, we humans, but energy in general is a requirement for any imaginable form of life. Ultimately, in this phase of universal history, the source of energy is matter-energy conversion, taking matter and converting it into energy. Now, nuclear energy is rather inefficient. We can only get out less than 1% of the mass of hydrogen out in energy when we convert hydrogen into helium. It's even worse.
Like a hydrogen bomb.
Exactly. But there is a better way. If we could use this process, which nature itself used to create matter in the early part of the universe, then we would be able to completely convert hydrogen into energy. And that is the ultimate energy source in the expanding phase of the universe.